Hello students, Assalamu alaikum, Bismillahirrahmanirrahim. Welcome you all in my new lecture series that is related with the analysis of different types of beams, statically determinate and statically indeterminate beams. And inshallah you will learn those beams, that how those shear force and bending moment diagrams are drawn in SAF program, that is structure analysis and program, how we basically analyze different types of structures like beams, 2D frames and 2D trusses, as well design of multi-story buildings like frame structures. So you will learn all those lectures as well. And inshallah I will cover different types of um, beams. There may be overhang beams, simply supported beams and cantilever beams, as well as 2D frames, one way, two way, one way, two way. Okay, and you will also see that how we analyze them for gravity loads, inshallah, and for different types of lateral loads. Okay, so I will cover this book, that is the fourth edition by Andrew Pytel Ferdinand Clare Singer. That is a Singer book and one of the famous book, you can say, which is teach in the universities. Okay, and similarly I will also cover some kind of examples from structure analysis, that is 8th edition of R.C. Habler. So in this book inshallah you will see that how we will analyze different determinate structures and indeterminate structures. So I will cover this book as well, and here you can also see that how we can analyze different approximate analysis of statically indeterminate structures, as well as you will see that how we analyze different indeterminate structures. Okay, indeterminate structures through structure analysis program. Okay, so these kind of lectures will be much fruitful for you peoples if you watch them. Okay, so we will start our first lecture series. In this lecture inshallah I will try my best to solve this example. Okay, this is a simply supported, this is an overhang beam. Okay, which is overhang on one side, and you see that this is the this is the ruler support, and this is the hinge support. Clear? And 50 kilonewton load is at point C, which is 2 meter from this support and 3 meter from this support. Okay, so let's see how we will analyze this structure, this beam, in SAF structure analysis program. This is the, you can say, the display of structure analysis program. Before starting any kind of example, any kind of structure, if you are designing them, if you are analyzing them, the structure, you must need to first of all check your units. Okay, you need uh, to select those units in which you are want to analyze your structure. So if we come here and you if you look to this example, that is in the units of kilonewton and meter. So basically we will select first of all our units, that will be kilonewton meter. Okay, then we will bring then we will bring this kind of beam. Okay, so to bring this kind of beams, you have in a SAF you have different types of options. Okay, I will explain these options in my succession of lectures, that how you can use different types of these templates. Okay, these are the templates. Here you can check your units whether it is kilonewton or meter, consistent with the units just in the corner of the screen. Clear? After that, as we are analyzing the beam structure, so we select beam. Although we can select grids, we can select grid structure as well. So I will explain these templates in my next succession of lectures. Clear? So first of all we will start our first example with beam. Okay, so this is beam. Here you can put the number of spans, as if we look to the beam. Okay, okay. This is basically to, there are two number of spans, okay. One is BD span and one is AB span, so there are two spans basically, clear. So we will go, or we will select two span, okay. Now we have to give span length. If we look here, so here the span is different and here the span is different, so there we need to edit, okay. We can only give only one span, okay. We cannot give different spacing in this template as we will select here, okay. So there is only one option. What we basically did here, we just select 2 and 3, that is 5 meter, so we just put here 5 meter, clear. And then we select or check this box, clear. Once we check this box, you need to select this edit grid, okay. So in this edit grid, basically first of all you need to check your units, leaving the rest of things, select this option spacing, okay. I will explain that what ordinate means and what spacing means, but here we are working on spacing, okay. So we select spacing, clear. Then A to B, okay. Then A to B. So basically there is 5 and the next span is, that is A to B and B to C, okay. So if I select this is 1 and this is 5 meter, okay. So let's see, check it, clear, okay, and okay, clear. So you have two windows, okay. You have two windows. You need to remove one window, okay. That will be, let's say I will remove this one, okay. You need to select exit plane, clear. This should be exit plane. XY, this is the 2D horizontal plane, and exit is the vertical plane, clear. Z is the direction which representing the height of the structure, okay. So here you can see this is the beam, this is the overhang beam, clear. Here we have ruler support. You can check the distances, clear. This distance is basically, you can see here, clear. The distances you can see here, X, Y, Z. So this is the origin point, so the distance is basically measured from this origin point. So if you are this point, you can see that your X distance is 1 meter, your Y distance is 0 and Z distance is 0, clear. So this means that this ruler support is a distance of 1 meter from this origin point, and similarly if you are click here, you can see X is -4. -4 means that you at the origin point this ruler is -4, so 1 plus 4 gives you the distance between this and this ruler, which comes out to be 5 meter. And similarly if you click here, you can see -5. -5 means as you are going in opposite direction to X, because positive X will be in the X direction, okay, in this X direction. And once you are going in opposite direction, you are moving in opposite direction of X, so your distance will be negative. That will be counted as negative, clear. So this is -5, so this -5 means that this is the free end, okay. Now we have overhang beam, okay. So we need to remove this this support, clear. We select this support. Selection is you can see once you select this support, you can see this kind of cross here, okay. You come to assign, you select the assign menu, okay, then join, then restraints. You need to select restraints, clear. Here you need to select this dot option, clear. This dot option means that this is only a dot and there will be no reaction on this support. This is just only a free end, you can say, clear. And just click OK. So you see the joint will be, or the support will be removed now, okay. So here you select again this free end, and if you comes to the question, you see that there is a ruler, so we need to bring again ruler here. You come to assign, select restrain, and this is the fact support, this is the hinge support, and this is the ruler support. Clear? So you need to just click on ruler. So ruler only give you one restraint, okay, that is in one direction. So you see that is give you one restraint. Okay, you just what this 3 2 1 means, I will explain these in my coming lectures. Okay, I don't want to waste my time. Okay, translation 3 2 1 means basically here 1 2 3 are basically representing the x-axis. Clear? So this means 1 means x-axis, 2 means y-axis, and 3 means z-axis. This means that ruler will only restrain you in z direction, not it restraining you in x direction. The beam can move in this direction, the beam can move in y direction. Clear? As well as the beam cannot move in upward and downward direction. Clear? So you need to select ruler. Now there is hinge support, so we need to bring hinge supports right there. Select joint, again the same procedure, you need to select hinges. Now you see that hinge can restrain you in y direction as well as in z direction as well as in x direction, but it can't restrain rotations. Okay, so you must know restriction. If you select fixed support, you know fixed support has a property that can restrain translations. Translation means horizontal displacement while rotation. Okay, so we don't need to select fixed support, we need to select hinge support. Clear? And just click OK. So this is your overhang beam right now. Clear? This is the overhang beam. There is ruler, there is hinge support. Now we need to assign loads. Okay, so first of all you need to edit the data, then you need to select the proper joints, and now we will assign the loading. So you can see that at the free end there is 30 kilonewton. Clear? So by assigning upload loading there are different methods. I will explain these methods in my coming lectures one by one. Okay, so first I will explain you the first procedure. You need to select this portion. Okay, you need to come and select assign menu. You need to come with to select frame loads. Okay, and then select point load. Clear? Here you can see uh, different options. Okay, you first of all you need to select kilonewton meter. Clear? This kind of unit. Okay, then you need to select this dead load. If you have live load, if you have dead load, if you have different types of loads, you can select that case of load. Clear? Then you need to close the self-weight multiplier. Okay, now self-weight multiplier means that whether you have to count the self-weight of the beam or not. If there basically in this example, the example which is shown here they ignore the self-weight of the beam. Clear? So therefore while analyzing this beam in a shape, we need to close the self-weight multiplier of this beam. That this process means that the shape cannot count the self-weight, means ignore the self-weight of this beam. Clear? So therefore we just select this plus option. Clear? Here you can see this is the multiplier, self-weight multiplier. If you leave this option as 1, the safe will take the self-weight of the beam, and if you select as equals to 0 and then just only press modify load factor. Clear? And just OK. Now this option, when once you select 0 in that self-weight multiplier, this means that the safe will not consider the self-weight of this beam. Clear? There are different options. I will explain those options, that how you can off the self-weight multiplier. Okay, so I will explain in my coming lectures as well. So now you have to, whether you have a movement, if you are want to apply movement or you are want to apply force. So as you can see that this is a force, not a movement. So therefore we will select this option, force. Then we have global coordinate system, that is leave for the time being, it is okay. Similarly, we have to apply loading in x, y, z and gravity. So you need to, at this moment you need to select gravity, because this is the load which is acting in the gravity direction. Clear? uh, Similarly, as the load is acting at a zero distance, so this is okay. You need to select the absolute distances, not this one, okay, because this one is little bit complicated. I will explain them in later lectures. For the time being, you just select absolute distance. Clear? At distance 0, you have to apply a load of 30 kilonewton. So you just need to select 30 kilonewton. Clear? And always press this button. Clear? Add to existing load. Add to existing load means it will add this 30 kilonewton load with already existing loads. Okay, if you replace existing loads, it will remove the existing load and will count new load. Okay, delete existing load means it will delete the other load, okay, which is present at the beam. Clear? So you just select okay. Now you will see 30 kilonewton is assigned to your beam. Clear? Now we have to assign another load, that is that is your another load, that is also a point load. Your self multiplier is now equals to 0. The same procedure, you just select force, you just select add, check the kilonewton. Once you select 0, but then they work, okay, for all types of loading. Clear? You just select here only 50, because we have 50 kilonewton. Clear? We have 50 kilonewton, but the distance is different. The distance is at 3 meter. Clear? So here you can choose 3 meter. Clear? And absolute distance, okay. So you see that this point load which is acting at this point will be at a distance of 50 meter from this support. Okay, so you must need, once you select this structure, okay, it will counting the distance from this point. Clear? This is the absolute distances. Clear? Not it will considering from this origin point. Clear? Once you select this structure, and you this 0 starts from this side, because if you look there, you see that this is distance and load. Okay, so this is your right support. Clear? It is sorry, left support. This is left. The distance is measured from the left support. Clear? So this distance is basically measured from the left support. Okay, now the beam is sorry, control Z. Okay, the beam is done, and in next inshallah we will going to analyze the structure. Clear? So this is the beam right now. We assign in first, if we will just only adjust the spans of the beam, and then we assign the proper joints. Okay, and then we will assign the loads. Okay, so now the next step is that we have to analyze the structure. So to analyze this beam, we have different options. Okay, we can analyze the structure from this menu as well by just selecting this option. Okay, and you can select here the analyze option, but for the time being ignore this step. Okay, just press this run analysis button. Okay, we will inshallah in later lectures we will discuss these options as well. Okay, so for the time being just leave those steps and just press this analysis run button. Clear? Here you have to select this model. Okay, we don't want to run the model analysis. Okay, in model analysis we will basically a little bit discuss about this. Okay, in later lectures, in coming lectures. Clear? But for the time being you just need to select do not run model analysis. Clear? We have only run the dead load case. Okay, and just press the run button. Okay, now the structure, you need to, before the running of any structure, you need to save that structure, clear, that file, clear. So let's say this is overhang beam, overhang, clear, and I will create a new folder. Okay, and I will save this file in that folder. This is the now analysis is complete. Okay, and this is the deformed shape of the beam, clear. Now the next step is that we need to check the reaction, that whether RB reaction is 56 kilonewton and this RD reaction is 24 kilonewton. Okay, so we will check the reaction, clear. So for this purpose you need to select this show forces, okay, this button, clear, and then you select this option joint, clear. Here if you have dead load, live load or different load combos or cases, okay, we will discuss in these kind of load combos and lectures, cases in our coming lectures, clear. So for the time being we have only dead load, clear, and you just click the OK button. These are the reactions, clear. 56, 24 kilonewton, you need to check it. Okay, 56 and 24 kilonewton, this is done. Now we need to check the shear force diagram, clear. The in the overhang portion there is minus 30 kilonewton, okay, which is constant, and between this point load and this support you see that there is 26 kilonewton, and after this 50 kilonewton to this support there is 24 kilonewton. Let's see. To see the shear force diagram, you need to again select this button, okay, and then you select this frame option, clear. Here you can select the cases or load combos which you will assign, but for the time being there is no load cases or combos. Okay, if you want to check the shear force diagram, there you can see axial force, shear 2-2, shear 3-3. I will discuss these options in coming lecture, clear. For the time being you just need to select shear 2-2. Shear 2-2 means you have one x-axis which is denoted by the 1-1 axis, and x-axis that the stresses which is, you can say, axial forces, okay, that is maybe compression and maybe tension, okay, and shear 2-2 means this is the shear force along the y direction, clear, and 3-3 that is along the z direction. So for the time being you just select this shear 2-2, and you can select scale factor as well for clearance of these values, okay, so leave it auto, and if you select the fill diagram you will see like shear diagram in this shape. If you select the show values diagram you will see the values, so you can see 30 kilonewton where also there 30 kilonewton, okay, 26 kilonewton and 24 kilonewton, you can confirm it, okay, so 30, 26, 24, okay, so this is clear. And if you want to select if you want to check the bending moment diagram, you need to at this time if you want to make clear these values, you can go to option button, and here you can select the dimensions, and this dimension button you can select the these two option, okay. Let's say this is, I will select it to 8 and I will select it to, let's say, 12, okay, so you can see the values right now, okay. So if sometimes these values are not properly clear, so to make it clear you can change those options and you will increase or decrease this font size, clear, text size, sorry. If you are interested to see the moment diagram, so here you can select the moment about 3-3. Always we select shear 2-2 and moment 3-3, clear. So now we will want to see the movement diagram. Just pressing OK. This is the movement diagram. This is the negative movement, okay, and this is the positive movement. Clear? So let's see. Minus 30 kilonewton and 56 kilonewton. This should be remember that SAP basically give you the bending moment diagram and shear force diagram along the tension side, because the negative diagram is to the upward. This means that you have to provide the negative steel at the upper portion, and the positive reinforcement in this portion you have to downward portion. And you can see here the point of inflection that is representing, or you can say that showing you that this is the point of inflection where the bending moment comes out to be 0. So you can see this distance. You can determine it by just clicking the right button. Okay, if you press the right button, this kind of window is coming to the coming into factor. Clear? Here you can select your load case. If you have different load case, 1.2 update load and 1.6 apply load, and similarly 1.4 update load, something like that. So you can select those load combos or cases. Okay, and here you can scroll values, show maximum and minimum value. These are the maximum shear value in this positive region in between the two supports. Okay, not for overhang portion. And this is the maximum moment, and this is the maximum deflection. Clear? That is the maximum deflection is at a distance of 3 meter. Okay, which is 0.005, say 5 millimeter. Clear? And this is the maximum moment, that is 48 kilonewton meter, and the maximum shear is minus 26 kilonewton. Okay, if you want to see the values at different locations, so now you can scroll this option, and you can see the values of shear and bending moment and deflection at various points. Okay, so if you are interested to find out the distance of point of inflection, you scroll this cursor, okay, and just bring them at the point where the movement comes out to be 0. So you can see 1.15, and here you can see that the point of inflection lies at a distance of 1.15. So this is very important, because whenever we are doing our design, basically PRC design, reinforced design of the beam, so we need this point, because to look at this point of inflection, we checking the development length for the positive bars and for the negative bars. So for that purpose we need this distance sometime. Okay, and for that purpose the importance of this point is very great. Clear? And if you are interested that what will be the importance of this point, please watch my video which is related to development length, so you can see the importance of this point. And this point can also be determined by various formulas. Okay, so those formulas and those procedures will be here, and I will also discuss those procedures in those lectures. So please watch those lectures. You can know the importance of that the point of inflection in PLC designing, as well as how to look at these distance. Okay, so this is the procedure. Okay, you can just change the units as well. Okay, and you can select the maximum and minimum. In coming lecture, inshallah, we will discuss a little more about this window. Okay, if you want to see the detail of this portion, so you just bring the cursor over this portion and just press the right button. Clear? So this is the overhang portion. Clear? And the maximum movement is here. If you select the maximum, show maximum value, so the maximum value of bending moment for overhang, that is minus 30, and maximum positive shear you can see here. Clear? So this is the procedure for analysis of a beam. Okay, for point load. and how to use different options. For this lecture I think this is enough. See you inshallah in next lecture. In next lecture, okay, in that lecture I am trying to analyze an overhang beam with a different loading, clear? And I inshallah I will trying my best to analyze the same beam. So if you have any question, any doubts about this, any suggestion about this, uh, you can contact me on my through email and through my cell number as well. And please watch the videos, and for any positive comments I am present.